We've been taught a lie about math, and that's why most students hate it. We've been taught that it's all about numbers and formulas and equations and worksheets and, well, the dread of the math test, right? But that's not what math was designed for. And we have kind of turned it into something and made it into almost memorization and boredom. So let's take a look back about what it was created for, something much bigger that will help us see why it was important and maybe even see why we could have fun learning it today. So somewhere along the way, math has turned into something that, all I remember is doing memorization sheets, and then we get into equations and things like that, and a lot of times not knowing what I was doing. Real math started for reasons and to solve real problems. And in the past couple of videos, that's what we've been trying to talk about, because that's one of the things that we hear from our customers all the time is, hey, my students don't understand what the point of math is. I get it. So let me kind of give you a real picture. Let's talk about some of the early stories, if you will, that drove us to math. And so think about being in Mesopotamia. Think about being on a ship back, thousands of years ago. You're on a ship, you're in the Mediterranean Sea, you're trading grain, you're trading cloth, you're going back and forth between different countries, and you are having some basic economic problems. So money isn't standardized. Right? It's not like we have dollars and different coins and everything for different countries like we do now. There was no real standardization of what was going on in money. And guess what? People cheated. So you needed a way to keep track. You needed a way to keep track of what you were owed and what you owe. And so how do you do that? And you didn't have it on paper. You're not going to do this with equations. You're not going to do this on paper necessarily. You don't have a calculator. You don't have a spreadsheet. But you have questions like, if I give you this much today and give you that much next week, how do we know we're even? Right? Kind of a common question, right? If one bundle is worth 4 measures of barley and you want 6 bundles of wool, how much barley do you owe him? So that's a real question, right? This is the questions we would ask today, and you might recognize this looks a lot like word problems. That's algebra. Everything that we just said is algebra. It turns into an algebraic equation. It didn't come from a textbook. This came from real people just trying to solve real everyday problems, and things got complicated. But they needed to survive. They needed to know they were treated fairly. They needed to know that they were using their money, whatever the source of money was, wisely. And so algebra came as a tool, not as a torture device. At this point, there is no X that we're looking for, right? There is no variable, if you will say, if you will call it that. If we flip over to geometry, though, and you think about the farmers who invented it, is a lot of what we think about geometry comes from Egypt, as we've talked about in some of the previous videos. But there was things going on that when you had floods, as we talked about in some of the previous videos, you had floods, and the flood would, just like it would today, it destroys property lines, it moves fences, it moves landmarks, and you just kind of got total chaos going around because you don't know where anything is. You don't know what's yours, you don't know what's his, and how do you know where the lines are? And of course, if you want to cheat, a flood is a great time to do it. So they had problems like, how do we draw the lines so that it's fair? They needed a way to measure that land fairly. That's really geometry. It's not triangles. It's not on a test, but it was triangles. And the test was, I'm trying to keep what I've earned. I'm trying to be treated fairly. It was a system for fairness and ownership. So some other questions that they had at that time was, how do we measure the area of a field that's shaped nothing like a rectangle, right? And when we think about fields today, looking at property maps, there's rectangulars, there's nice perfect lots. but there's not always. Like in a neighborhood, many times that we'll have lots that are more triangular in shape or some other kind of odd shape. Well, if I'm trying to divide that between my kids and I want to be fair, I need some tools to do that. All right, and we could just guess, but as we got better and better tools, or maybe they were more and more important because it wasn't just the merchant's land, it was the king's land. So you needed to be careful about how you did things. How do you build a perfectly level foundation? Common problem today, right? So a massive stone won't collapse. I need to build a foundation of a large area that's level, because everything depends upon that being level to keep the building, especially as you go up in a building or as you start to have corners in a building, and the larger it gets, the more important level is, because you end up with weird shapes instead of what you expect to be boxes or rectangles or squares. So how do we angle ramps to haul multi-ton stones? That was a common thing going on in Egypt, is we were hauling very, very large stones. We were building monuments. We were building buildings. That was actually going on in other countries too. But we didn't want to break the ropes. We wanted to have tension, and we weren't breaking the ropes. We just had all these kind of problems that you think of today. Well, if you take some kids going in the backyard and they start building things, they run into these same challenges, right? Well, that rope is not strong enough; it breaks. Well, that doesn't hold it up. But as we're building bigger and bigger things, these problems became more significant. Days and days and weeks of work get shattered. People get injured. People get killed. So even how wide should the base of the pyramid? One of the things about the pyramid, the height mattered a lot to them. How big does the base need to be to get to the height that I want? Right. So these are things that we would think of today, and even today we might have some tools to calculate these things, software, but they're all based upon math. But at that time, they didn't have the software, they didn't have the calculators, they didn't have the instrumentation. So what were they doing? So let's move forward though. So because we've talked about geometry a little bit, but we haven't talked about the trigonometry. And trigonometry and calculus are some interesting things. Is they didn't come from the classroom either. As a matter of fact, none of this stuff is in the classroom. What we're trying to do in the classroom is teach people these tools. And unfortunately, we don't do it very well, because we have turned it into equations. We've turned it into memorization. We've turned it into things that make us hate math. So if you're a sailor in the Mediterranean, you're back there on the Mediterranean Sea, like I was talking about before, but now you're the sailor and you have to navigate. And how did they navigate? They navigated by planets and the stars. They didn't have GPS. They didn't even really have good maps, but they had the stars, and they were really good at using the stars and the planets. But if you were wrong by a few degrees, you would make it to the wrong place, and you would make it home. And as we got out from the Mediterranean, we got into the Atlantic, and we got some of these other oceans, that became even much more critical, right? So, and we still didn't have GPS, right? If we think about the days of those people exploring the United States, and the early explorers in the Pacific and the Atlantic, they didn't have GPS, and they were in a big wide ocean. So sailors created ways to measure angles, distances, and direction. Your angle you're going, the distance you're going, the direction you're going, and it wasn't because it was on the test. It was because they needed to survive. They needed to get to where they needed to get to, partly because their life depended upon it. And of course, they were carrying supplies, or they were exploring, whatever they were doing, they needed to get to a particular location. So this is what was going on then. Trig was a survival skill. They started developing trigonometric tools, and you see the old tools that we might have used on ships and the navigation that they might have used. And they're based upon trigonometric principles. But if we move forward, so everything seems to come back to measurements, right? so much was going on then that we had to measure from the stars and the planets. And but that's difficult because they're moving, right? They're moving, we're moving, and as we begin to understand all this better, we realize there's things that we don't understand how to do. Normal equations, normal math dealt with things, but it didn't deal with change. Like when you drop a ball, it starts at 0 miles per hour, but as the further along it gets, the faster it goes. It didn't deal with changes, and it didn't deal with motion very well. So when you get into motion, things were more difficult. Astronomers and scientists were trying to predict where the planets would be. And that's a big, tall order. For you don't really know much, or you're sitting on Earth, you don't have any of the tools we have today. But I need to know where that planet is going to be. I may need to know how objects fall, how they accelerate, how fast a planet is moving at an exact moment, and where it will be next. I mean, think about that. We have apps on our phone today that will tell us right where our planets are. And how are they doing that? Thinking about that, they'll tell us where our planets will be tomorrow. And because we have learned to predict that. And why? That's math. So why? I remember thinking at one time, why did we care so much about this? Why did we care about the planets? I get the guys navigating. But the movement of the sun and the moon and the visible planets told ancient people a lot of things that maybe an old farmer might know today, but we don't do this quite the same way. It told them when to plant their crops, when to harvest, when to store food, when to prepare for winter. They didn't have the same calendar system we have. They couldn't just look on a date, well, it's time to go, plow the field. They had to go by the stars, the planets. Sailors also, of course, as we said, navigated that way without the tools that we have today. But some other interesting things, as you might find, is kings and priests and astronomers who could predict the eclipses, right? The eclipse of the suns, the eclipse of the moons, or other celestial events. If you could predict those things, you were seen as magical. It was a magic power, and that was power. Right, we saw this going on in Babylon. We saw this going on in Egypt. We saw this going on in China. That the kings and the astronomers, and if you read in the Bible, you'll see all the wise men coming, or even in Babylon and Nebuchadnezzar's time. When we're in the book of Daniel, you see that Daniel became one of the wise men. And these are people that are doing things like this. They're reading the planets. They have learned to understand, so they can tell the king things. And then the king looks brilliant and looks like the king has incredible power. So predicting an eclipse gave rulers enormous political power. Enormous political power, because everyone else thought the heavens were speaking to them. As a matter of fact, you might know that in 1504, maybe a later time, but in 1504, Columbus used this in a famous story. So Columbus used an eclipse for the prediction from an almanac. Now, where some scientists or some astronomers had documented some things in an almanac, and he predicted. Now he knew, kind of like we might know today. Hey, there's going to be an eclipse of the moon tomorrow. And even our weathermen tell us to go out and look for the eclipse of the moon, and we do these events. But they didn't know that then. But Columbus now had this in an almanac, and when he was in Jamaica, some tribes were there, some of the native tribes, and they wouldn't feed him. And he told them if they didn't feed his troops or his crew, that God would make the moon disappear. And of course it did, because of the eclipse, and they got scared and they panicked and they obeyed Columbus. So we see people using these tools all along for maybe crazy reasons today, but for power. We see them using it for safety. We see them used for livelihood. And all these tools that have been used, and of course there's many others, the statistical tools, there's all these things that have been developed over the time that they're not made to bore us into classroom. They're not made just for the sake of punishing Johnny on the weekend so he's got to do all of his math homework. No, they are made to solve real world problems that we still have today. We have better tools, of course, but the math is still there. And there's no way we're going to get even better tools, right? There's no way that the iPhone gets better or GPS gets better or your gaming system, something that might be important more to us, our games become better without math. It's the underpinning of all these things and the motion and the complexity there. So farmers had this problem. Astronomers had this problem. Sailors had this problem. Kings and queens had this problem. But what is it that we've got today? What are the common problems we got today? And it's not just in the worksheet. And this is why we don't really like math, is because most of us don't understand this. As we talk about this, maybe in the beginning of the math course, maybe a snippet, but we don't focus on the interesting parts of the math. We focus on just, okay, well, here's an equation, solve for y. Okay, but so if you're a teen or any grade hates math, maybe it's not their fault. Maybe it is the way it's been taught. I don't mean the teachers, but the system. It's just been taught. It's been taught as a tool to get people to do things instead of to actually educate. This is the difference between being able to do like a robot and to educate or actually know what's going on. So math is used is a language, and it's about relationships of things. The planets, the stars, motion, the seasons, all of these things have relationship. Once you start to see the real story behind math, and oftentimes we see this in what we would say is the sciences, but we might also consider business as science or sociology as science or any of these things where we're using data and statistical analysis. It all turns into a mathematic equation that we're trying to use to solve problems for us today. As you look at AI and the big booming of AI, what's behind it? It's looking for patterns. It's trying to solve problems for you and I. It's math. It's math. It's not that necessarily that complicated of math, but it's math. So if you want your teen or yourself to enjoy math, always start looking for the story behind the math. If you like this kind of video, go down below, check subscribe, and we will be sending you more of them. See you next week.